This is Mrs. Mahler. Miss Liz and I aren't going to be here for the next few days, and we're really sorry, but we have all the confidence in the world that you guys are going to be very successful by just watching these videos. Remember, they'll also be posted on School Loop, so you can re-watch them and pause as you're watching them now. So just let the sub know what you'd like to do. First of all, make sure you've picked up your stamp sheet. Answers to the cumulative is what we're going to be doing today. We're going to do our lesson, and then you're going to have plenty of homework time. And if you finish your homework, you can go ahead and work on your next cumulative. So let's go ahead and get started. All right. So at this time, if you don't already have your cumulative folder, let's go ahead and pass those back. Okay, so let's look over the cumulative number 3 take-home test. So you guys did pretty good on number 1. Number 1 was x equals 9. All you had to do is move the square root of 2x plus 8 to the other side and then square both sides. This one, you had to factor the numerator first, and then as those cancel or equal to 1, you're only left with f of x is equal to x plus 4, which is just a line. However, x cannot equal negative 2. Well, where x equals negative 2 is all along this line, and it happens to pass the graph right there. So there's a hole there. Let's see. What else here? Number 3. Okay, so this one you can't factor, so you actually have to do the long division here. And as you do the long division, you would get 4 plus 1 over x minus 1. But we normally write that like this up here with the plus 4 in the back. This would be that 1 over x minus h, where this is your horizontal shift, plus k, where this is your vertical shift. And that's what made it shift over to the right and shift up 4, and then there was no stretch. So it just looks like this. Your graph looks like that. This one I was really surprised. Many people were able to get here, and then they actually canceled 3y's in the numerator and 3y's in the denominator, and then said it was equal to y instead of 1 over y. I don't know if Miss Liz's class was like this, but my class did this a lot. So that one was wrong. So yikes, not supposed to do that. So you can't just say, that's like saying this. Let's see, 2 times 2 over 2 times 2 times 2, and then canceling the 2's, and your answer is actually 1/2, but saying my answer is 2. 2 is not the same as 1/2. So y is not the same as 1 divided by y. So that's your answer right there. All right, moving on. You guys did pretty good on this one. So you've got a horizontal shift of -1, a vertical shift of -3, that's what brought you here, and then there was a stretch of 2. So it's over 1 up 2, and over 4 up 4. You guys did pretty good on this one as well. Again, you've got a horizontal shift of -2 and a vertical shift of 1. So -2 up 1, and since it's a cube root function, it should look like this. A cubic function would look like this. Number 7, factor by grouping. I think the biggest mistake on this one is many people got here, but that's not completely in factored form. This is in factored form because x squared minus 4 is the difference of 2 squares. So you have x plus 2 and x minus 2, and it could have been written like this with x plus 2 having a multiplicity of 2. Miss Liz wrote it like this. Many of my students wrote it like this. Even though we showed you that this was appropriate, when we're talking about a graph, I think it's more appropriate to write it like this. I've got a 0 at 2, 0, and I've got a 0 at -2, 0, but this one is a little bit messy. This one had a multiplicity of 2. or a double root. All right, moving on. Number 8, find all the zeros. Many different ways. Your zeros are actually -5, -1, and 3. So you could have started off with -5 and then found -1 and 3 by factoring. So it all depended on where you started here. But you had to show us that you could actually find the roots using synthetic division. That was the only way to do it. So here are our zeros. 3, 0, it's a double root. -1, 0, -5, 0, and the y-intercept was 0, 45. Your graph should look like this. It's like Miss Viz on her key here, she was counting by 5s. Number 9. This one you had to recognize that this here factors to x plus 5 times x minus 3. And that being said, if I wanted to clear this whole denominator here, you had to multiply this one right here by what it doesn't have, which is x minus 3. You had to multiply this one here by what it doesn't have, which is x plus 5. This one has everything in the denominator, so you don't have to multiply it by anything. So when you multiply this out, you get this. When you multiply this out, you get this, which equals x plus 61, which is right here. Then if you combine like terms, move everything to solve for 0, and that's how you find your zeros. Now, so your answer was x equals 7 and x equals 3, but if I put 3 right here, x cannot equal 3, and x cannot equal -5, because that would make those denominators 0. So since those were your excluded values, x equals 3 is not a solution. So x equals -7 is your only solution. Okay, number 10. This was just straight long division. If you did this correctly, you got a remainder of 2, and you should have written it. I required that you at least had this side of it. I know there wasn't a lot of room to write it, but at least had this right here. So 4x plus 1, where'd my pointer go? 4x plus 1 times x squared plus x minus 1 will give you 4x cubed plus 5x squared minus 3x plus 1. My pointer's not working very well right now. Sorry about that. Okay, so let's move on. All right, what is a logarithm? Logarithms are exponents. So if a logarithm is an exponent, then when do we need logarithms? Well, we need logarithms when we can't find an exponent. And we're looking for an exponent. Okay, so let's review the power to a power property. So if I have b, or a base, to the power of m, or my exponent m, and it's raised to a power, it's the same thing as saying b is being raised to n times n. So since logarithms are exponents, logarithms share the same properties. So since this logarithm is an exponent, let me just pause this and change this. Let's try this again. So since logarithms are exponents, then when we raise them to a power, as this one's being raised, this exponent is being raised to a power, then we can actually say that we can multiply the exponent and the power. So in essence, it's just like taking that power and bringing it out in front so it can be multiplied. Okay. Actually, I wanted to go back to this screen and talk about when we use logarithms. I thought that was on the next page, so let me say this. So if I have 2 to some power equals 8, we can clearly see that 2 cubed equals 8 because we can have common bases. So now we know that since we have common bases, we can compare their exponents. So I can say x equals 3. That's easy to see. But when you have something like this where it's 2, bring this back up. When you have something like 2 to the x equals 9, I can't make these common bases. And this, so I'm looking for this exponent, and that's when we use logarithms. So I would say log of both sides, and then I will use that power to a power rule and bring that x, since logarithms are exponents, bring that x out here. And now we can solve for x. Okay, let's look at a couple other properties. We also have your product property. When you're multiplying two bases that both have exponents, then you can just add the exponents. Well, I can do the same thing with my logarithms. Can you guess how I would use the product property when I've got two factors being multiplied within a logarithm? For instance, if we had log of, let's say, 30. Log of 30. Log of 30 could be rewritten as log of 5 times 6. Well, 5 times 6 can be rewritten, since multiplying means we can add exponents. Well, these are exponents. Logarithms are exponents. So we can rewrite this as log of 5 plus log of 6. And that's what this rule says right here. I can split them up, the m and the n. Let's look at another one. Quotient property. Okay, so with the quotient property, let's use something like, let's see, how about b cubed over b squared. We'll keep it simple. Well, b cubed over b squared is just like writing b times b over b times b. Well, b divided by b is just 1, and b divided by b is just 1, and I'm left with just 1b. Well, there's kind of a shortcut to this. We could have rewritten this. We could have written this as, I have b cubed. B squared, if I bring it into the numerator, is going to be b to the negative 2. Well, now I can use my product property and combine those two exponents, and 3 minus 2 is just 1, so I have just b, just like I had before. Let's look what that looks like with this quotient property. So it's saying that b to the m minus n comes from when I have a quotient of a numerator. The numerator is always the first one, and the denominator is always the one that gets the negative sign. Well, let's use the quotient property with logarithms. So hopefully by now, you can go ahead and sense that I'm going to have log n, and we're going to subtract log n. So let's use these properties. Students will be able to manipulate expressions using the properties of logarithms. Students will be able to describe which property is appropriate when manipulating logarithms. So why don't we get your stamp sheet out, the one that you just got today, and I know it says something like use a tree map. We're not going to use a tree map. Just go ahead and cross that off, and I want you to write these on the bottom of your stamp sheet for this week. So you're going to get credit for this. So write down your logarithm properties and pause the video. Okay. All right. How could we rewrite the following to use what's been given to us? So we have a few things here. We have log to the b to the 5 equals r. So whenever I have log b5, I can substitute in r. Whenever I have log b4, I can substitute in s. And whenever I have log b3, I can substitute t. So we're going to use this to rewrite log b of 20. So here I could use my product property right here. I could use my product property because I know that 20 is equivalent to 5 times 4. So let's go ahead and rewrite that as log b of 5, in the color code, times 4. All right, so using my product property, let's rewrite this as addition. So log b of 5 plus log b of 4. So here's my 5, and here's my 4. Well, let's substitute. I know what log b of 5 is. It's r. So let's just substitute that in for r, plus log b4 is s. Let's substitute in s. So log b20, using this information that we have up here, can be rewritten as r plus s. Let's try another one. All right, log b15 to the 4th. Well, in 15, I see a 5 and a 3. But this 4 right here, I can use the power property and bring that out in front. So let's use the power property on that one, which is this one. And I'm going to go ahead and take, my cursor is not letting me go above there. So let's take this, take that 4 and bring it out in front. It really doesn't like me writing right there. Bring that out in front and makes it a 4. So now I have 4 times log b times log b15. Well, I'm going to rewrite log b15 as log b5, the multiplication. Log b5 times 3. So now I can use my product property and turn this into addition by splitting it up into 2 logs. So I have 4 times log b of 5, which I'll rewrite, plus log b of 3, which I'll rewrite when I change my color. So log b5, my color didn't change. Log b5 plus log b3, and now I can just substitute those values. 4 log b5 is r, so we'll substitute in r, plus log b3 is t. So I have 4 r's plus a t. Should be writing equal signs here. They're all equivalent. Should have done on this one too. They're all equivalent. Alrighty. Can you guess what we're going to do on this one? Well, I have a quotient. So I can turn that into subtraction and turn it into 2 different logarithms. So let me go ahead and do that. Oh, it says log instead of log. Oops, I forgot to fix that. Alright, so we have log b of 20 minus log b of 64. Well, Well, the 20 is easy. That's just 5 times 4. So I could rewrite it log b 5 plus log b 4. That's this part. Let's see. I'll do it with orange. So that's this part right here, not orange. So that's now this. And I'm subtracting log b to the 64. Well, I don't have any 64s up here, but I do have a 4. And I know that 4 cubed is 64, so let's rewrite that as well. So I subtract log b 4 cubed. Now I can use that power property and bring that out in front. So I've got 3. It's actually going to come out here in front and be multiplication. All right, let's keep rewriting. Need equal signs here. Equals, equals, and I might as well, I'll just rewrite it. So log b5 plus log b4 minus 3 log b4. Now let's substitute. Log b5 is just r. Log b4, being lazy, I need to change my color a little bit more, is just r plus log b4, which is just s, minus 3 log b4s, which is also s. So I have 1s minus 3 s's, which just gives me negative 2 s's. So I have r minus 2s. Pretty straightforward. It's like a puzzle. You just got to figure out exactly what pieces go together. Okay, let's look at this one. Log b 1200ths. I'd like to rewrite it that way. Log b, clean that up a little bit. Log b 1200ths. We've got a quotient property. So that becomes log b 12 minus log b 100. Take a moment, see if you can figure out what we're going to do next. What's our time here? 23. We're doing pretty good. All right, so log b12 is we're going to use the product property for that one and turn it into 3 and a 4. So I have log b3 plus log b4 and log b to 100. Well, 100 is actually 25 times 4. We could do that. Let's just do that. We'll go slow. Log b is 25 times 4 equals, I'm not going to let me write right there, equals, no, don't stop on me now, equals log b3 is actually t. Let's just put the t now. We might as well. So t is green, substituting, plus log b4, which is s, minus, let's rewrite this. We're going to use the product property and make this addition, 2 different logs being added, but then at the same time, I'm also going to change this 25. So it's going to be log b5 squared plus log b4. Alrighty. So now I have a t plus an s minus 2, because I'm going to bring that 2 out in front, right? Now I've got log B5, which is really R, so I've got 2 R's, plus log B4, which is, I believe, S. Yep. So I've got a T plus an S plus another S minus a 2R. I'm going to rewrite that. I've got T plus 2 S's minus 2 R's. All right, I think that's it. Okay, so logarithms are, again, logarithms are exponents. Super, super important. Logarithms are exponents. Can you name each of the logarithm properties? We've got the power property. We'll write it as exponents. The power property, x to the m to the n. We've got the product property, x to the m times x to the n equals x to the m plus n. And you've got the quotient property, x to the m over x to the n equals x to the m minus n. Perfect. All right, time to do your homework. So let's go ahead and pass out homework, and pass out, the homework is a half sheet. You're going to do the front and the back. And we have a new cumulative number 4 take-home test. If you guys get finished with your homework, you can go ahead and get started on that cumulative.